Okay, in this first screencast about net force and acceleration, we're going to apply the laws of motion to a specific type of motion and see how it ties in with what we learned in kinematics. So we're going to have Luke out below dropping a 5 kilogram fat cat. Of course, we could be dropping anything. We're going to ignoring the effect of air resistance. We're just going to look at, on the way down, the driving force, if you will, the force that's going to make the cat accelerate. Is going to be its weight, which is approximately 50 newtons. Once the cat hits the water is going to generate an upward 50 newton resistance force, buoyancy force, against the motion of the cat. We're going to figure out which one of these velocity time graphs would best match the motion of the cat, and then figure out why. Well, we'll figure out why, and then we'll match it. So on the way down, we really have two different situations. And the free body diagram is the way to go. Before the cat hits the water, we have a downward force of gravity. Once the cat hits the water, we have a downward force of gravity of 50 newtons and an upward buoyancy force of 50 newtons. Now, the first one is unbalanced, and therefore the net force is not zero, and therefore we should have some number of acceleration. On the right-hand side, our forces are balanced, and therefore the acceleration should be zero as the net force is equal to zero. So we need something that has an acceleration, and as it falls it should speed up, and then once it hits the water it should reach. Now, it doesn't stop moving. Okay? This doesn't tell us the motion itself. It tells us that it's going to reach balanced forces, which means if it is in motion, it will continue in motion at a constant velocity. Since the cat is already moving, we're not going to go to zero velocity, but we're going to go to a constant velocity that's in the downward direction. So while the cat is falling in the air, it's going to be constant negative acceleration. And that means it's going to be getting faster as it falls into the negative territory. The line's going away from zero, so this one works for the beginning situation. And then after hitting the water, it's going to be constant negative velocity. So the velocity should stay the same, but be a negative number, and that section also works. So the correct answer is B. Okay, the cat doesn't stop when it hits the water, but it does stop speeding up. Okay, so if we're looking for a tape that would match that, we should see initially an increase in the distances between the dots, and then we should see, once it hits the water, which is where the arrow is, constantly spaced dots, because we're moving at a constant velocity. So tape A starts out very close, and then they get further apart, so that's good. And then once it hits the water, these are all the same. Now, it can't be tape C, because that would be slowing down. The cat's not slowing down. Okay, it's moving at a constant rate. And same thing here. That shows it's slowing down. So it's going to be tape A. We need faster. So increase in spacing. And then once it hits the water again, and this is where a lot of people go wrong. I think, well, it hits the water, the forces are now balanced, it must stop. No, once an object's in motion, its inertia will keep it in motion when the forces are balanced. So then we need a constant velocity. That means we need equal space. And the one that best matches that, the only one that comes close, is tape A. Several of Luke's friends were watching the motion of the falling cat. They just started discussing it, so let's see who we think is right and who we think is wrong. Let's do some peer review. Classic science. Somebody makes a statement, somebody else, others have to review that statement and try to indicate if they think it's right or not. So in our first one, once the cat hit the pool, the forces are balanced and the cat will stop. Well, that is not correct. Once the cat hit the pool, the forces are balanced. That is correct. But since the cat was moving, the law of inertia says if there are no unbalanced forces acting on an object that is in motion, it will continue to move in a straight line at constant speed. That means with constant velocity. So that does not mean it will stop. So balanced forces don't change your state of motion. So if you are moving, you will continue to move in exactly the same way, which is what our cat is doing. B, upon hitting the pool, the cat will accelerate upwards because the pool applies an upward force. Well, that also is not correct, but it's closer to being correct perhaps. If the upward force was unbalanced, then yes, it would accelerate upward. But we have two forces working here, gravity, and that's equal to the force of the water, the buoyant force. So actually, we don't have an unbalanced force, we have a balanced force. And if it's balanced, then the net force is equal to 0, and by definition, the acceleration is equal to 0. So it cannot accelerate. That's not possible if the forces are balanced. It will maintain its current state of motion. Part C, upon hitting the pool, the cat will bounce upwards due to the upward force. Now again, even if the force was greater, it probably would have to be very, very, very much greater to make it bounce. But again, the forces are not unbalanced. So because gravity is balancing the buoyant force, we're not going to get a bounce. It's going to continue to move in a straight line at constant speed because the forces are equal to 0, so the net force, the overall impacting force on the object is 0, and therefore there's no acceleration. It's not going to bounce if there's no acceleration. So no, it will hit the water, go through into the water, but we will see it moving with constant speed until it reaches the bottom of the pool, at which point, being a cat, we'd assume it would have flipped over on its feet and it would come to rest in a relatively quick fashion. Okay, so that's an example of applying the law of acceleration to a situation. Again, it is in analysis and a synthesis. You're tearing down the situation, looking at its individual parts, and then you're putting it back together again and seeing how it works as a whole. Those are upper level thinking skills. Don't expect to get this right away necessarily. It's going to take you some time to get your brain trained to think correctly. Keep working at it. Eventually it will all start to come together. And we'll look at the rest of this in episode number 2.